Grade 12, permutations and combinations. How would I continue this equation to find n? Okay, let's have a look. We are solving. np3 is equal to 990. So what does the p mean? How can we compute it? First, p stands for permutation, and the idea is it's about how many ways you can arrange however many items out of total many items. Examples helps. So here we go. Let's say if you are trying to compute 5p3. This number tells you how many ways we can arrange 3 items out of a total of 5 items. And the way to compute this is how I like to do it. You start with this number here, which is 5. And here we have 3. I need to have a total of 3 factors. So I need a next number, which is, go down by 1, which is 4. And then another one, which is 3. So 1, 2, 3 is 3 numbers. That's it. So imagine you have 5 students, pick 3 of them, and then have them sit somewhere. A, B, C is different than A, C, B, things like that. And just compute it. That's 20 times 3 is 60. Just like that. Another example, let's say if you are doing 7p2, you just do 7 times 6. Right? Start with 7 and you need to have 2 numbers, multiply them, you get 42. And if you have, let's say, 9p4, this means 9 times 8 times 7 times 6. The number is a little bit too big, so you guys help me. But anyways, that's the idea. So now, on the left-hand side, use the same idea. We start with n, and then the next one is n minus 1, and I need one more, which is n minus 2. So this represents np3, and we are going to get 990. Here's the deal. If you multiply this out and then arrange it, you'll be solving a cubic equation, which is not so easy to do. You can see that from the post right here. It's possible, but here's a slightly better way, I'll tell you that. Okay, our goal is that when we do this, n has to be a positive integer. So let me make a note. N has to be a positive integer, because it doesn't make sense to arrange like 5.8 things out of 10 things, 10.2 things. No, you can't. When you do combinations or permutations, it's just positive whole numbers. Sometimes 0, but that's another story. Anyways, how do we do it though? The key right here is that you look at 990, just kind of break it apart. That's how I would like to think about it. 990, I know, I almost wanted to write 999, but 990. 990 is the same as 99 times 10, fair. And then this right here, just kind of break it down. You want to keep the numbers kind of like even. This right here is 9 times 11. Guess what? N times n minus 1 times n minus 2 equals, the biggest number is 11 times 10 times 9. I know 10 is the same as 2 times 5, but I don't want to continue because 11, 10, 9, it's in a very nice order. And right here, I can say by observation, or whatever you want to call it, you can conclude that n is equal to 11. Just like that. Yeah, I hope this is a acceptable solution. If not, this is definitely not the way to solve any cubic equation. I will have to tell you that though, this equation here has one real solution, which is n equals 11, and that's exactly what we're looking for. And we do have 2 other complex solutions. Then you will just have to kind of use the rational zero theorem and kind of like test it out. You get 11, and then you are going to divide, do polynomial division and all that stuff. I'm not going to go through that for this question. If you guys want to see how to solve cubic equations in general, or maybe at like a pre-calculus level, check out my other videos for it. That's it.